Welcome in on a beautiful Sunday. How you doing, guys? On my bench today, I have a Nexus S1. You guys have seen these, the hot and first multi-chip miner to the market for the BM1373. Actually have one down here. See here that we've been testing, running. This is the one that was in my other video back here that had the cracked ASIC chips when I took the heat sink off. So I had a customer send this in on a repair. Let's see what version this is. Version 2.1. Customer sent this in for repair with a complaint about V-regs running hot. Let's see, I'll read the complaint to you. Voltage regulator overheating, can you replace all four? That was the ask. Let's see here. Let's get you zoomed in on the important stuff that you guys want to see. So I did an inspection on this board initially. And, you know, of course, I'm going to check the ASICs. And, of course, it looks like I have one cracked here, unfortunately. Of course, I don't know for sure if there's going to be really any impact. As we've seen on the other one that I have down there, still hashes away. I have heard that given the size of the new silicon, that these things are pretty susceptible to cracking. Again, it'd be concerning to me, but if it's hashing, it's hashing. So there's not much I can really say about that. Time will tell on longevity. So I started looking this device over for the customer to really do a visual inspection, which is what I usually do. And this is the first thing I came to. So I removed the V-Reg heatsink that they had placed on here. There's, I don't believe there's any shorts on this board. I don't think so, but we're going to find out. Now, the board's not reading any direct shorts on the power rail. But this is definitely not good. So I have, you know, I've worked on a lot of these CSD-driven multi-chip miners over the last 2 years. As these things first started coming out, as we built them, as other manufacturers started to build them. This is probably the first time I have seen these caps on the input side completely blown apart or coming off. I thought this was a really interesting find. So let's talk about a couple of the downsides with this Nexus S1 when it comes to this problem right here. This is not an open sourced hardware miner, so it can be difficult to fix if I don't know what the components are. Now, you know, there's obviously a lot of components are shared between the various versions of the such as the TVS diode. Obviously, this is a fuse holder that's easy. We have the CSDs. We've talked about this before. They use R22 coils. But sometimes the fan control chip's going to be the same. But sometimes some of these little components, these manufacturers will make a change on. Now, the downside is this change could lead to more failures, could bring more longevity. It's really hard to say. They're certainly free to make changes to the design. They were supposed to open source the design because they took an open source footprint as part of the license. That didn't happen. It can make it more difficult for me to find these components. However, what I have done is I've gone straight to Texas Instruments reference diagram for these CSDs for ideal conditions and what they recommend on the input capacitors. So that has given me a little bit of a clue. And the other thing I can do is take one of these off, one of these ones that look like they're good, and measure it myself with my meter, which is what I'm going to do just to validate. I've given the customer a quote. The first thing I need to do is replace these. I'm going to go ahead and replace all of these. I have suspicions because, you know, given the failure and across multiple things, and we don't have any shorts on the primary inputs on the power rail. I think one of two things has happened here. We either have a lack of solder, so we've got some bad connections, or we have a situation where these capacitors are not heat rated where they need to be. You know, you can get these caps in multiple different kind of heat ranges and tolerance ranges. So I don't know if this manufacturer went cheap and just got the cheapest capacitors they could buy and stuffed them on here. It's really, really hard to say. Again, I don't have their BOM, so I don't know for sure. But I know that this is a problem. So I'm going to have to replace all of these caps. And I will likely replace the CSDs at the same time for the customer because that's what they've asked. I've quoted the customer. Customer's given me the approval to do this. But I wanted to share with you guys I thought this was a really interesting one, so I'm going to go ahead and I'm going to get this up on my hot plate, and I'm going to remove one of these caps. We're going to measure. We're going to see what these are, and I'm going to give you a reference of what they should be, and then we're going to order up what we need, and then we're going to probably have to do a second video on the actual repair of this device. But unfortunate to see such a new miner that's already down and out, and the manufacturer is not supporting it. Not surprised, unfortunately, but you know, this is where we find ourselves. So let's see if we can't get this customer taken care of. Let's break out this hot plate. So I'm going to preheat this board. Let's get you adjusted here so you can see better. I'm going to preheat this board, and I'm going to take off one of these caps. Now, all of these capacitors should be the same rating. So this is our input rail, a 12-volt input rail to our CSD. All of these caps here should be the same rating. Now, these other caps that you see here, they're for other related circuits. You can see how they're broken out on the traces on the board, but the top layer, and these are multi-layer boards, but the top layer is all going to, this particular top layer is going to be all 12-volt hot from the input. So we're going to remove, well, let's see if I can grab one that's, yeah, I'll probably go for this guy here. And I'm going to shelter these caps as much as possible. I don't want to get electrolytic capacitors too hot, because they will remind you that they're not designed to get too hot if you're not careful. They can handle the reflow oven, but they're not going to handle a blast from some pretty good amount of heat. So we're going to shelter that. I also don't want to melt them. And we're going to let this board warm, get up to temperature. I've got it set up to 400 C. And this is usually a telltale sign when this is the first time I've done any work on one of these other than the evaluation I showed you guys. We're going to find out if the manufacturer used lead-free, high temp solder here pretty quick. So I'm going to get this board up to 400 C, and then we'll be back. All right, I think we're about up to temperature here. So I've gone ahead and changed my tip out to a smaller tip on here, and we're going to see if we can't get this cap out of circuit. When you're doing work like this, you want to make sure, especially capacitors, that you're checking out of circuit, especially when they're in parallel with other capacitors. So what I'm going to do is I want to shift this cap over. I just want to isolate it so I can measure it. Okay. So I'll leave it on the board, but I am going to isolate it here. Cool. Doesn't look like it melted anything. That's good. All right. Get our heat off. So I'm using a Fluke 115 True RMS multimeter, and I have the ability to measure capacitors with this. Let this cool down just a little bit. So I'm reading 7, 8 UF. It's kind of climbing, and with it being hot, I'm not surprised. So we've got a 10 UF capacitor here, approximately. This is what the actual schematic calls for, is a 10 UF with a 10% tolerance. So what I'm going to do is I'm going to order up these are 0603s. I'm going to order up at minimum, the proper heat range, the X5R, in a 10 UF, and we're going to replace all of these. I have no idea what these are. I certainly don't want this customer having the same problem again. And I really have no rhyme or reason as to why, other than either we used a low quality capacitor or we had issues with soldering joints. Really, really hard to say, but to see 3 of them on separate lines on the input side doing this, it's lead me to believe that we have a problem with the actual components themselves. Could be a bad run of caps for the manufacturer, which is unfortunate. Could be just low quality. It could be bad solder joints. The solder joints do not look fabulous on this, especially in this part of the board. But we're gonna go ahead and order these up for the customer, and then we're gonna swap out all these caps, and we're gonna swap out these CSDs, and then we're gonna test this board. Unfortunately, the way this is, I'm not gonna risk testing it and causing more damage, just the way it sits. So as soon as we get those components in, I'm expecting probably about a week. Then we'll shoot another video. We'll give you a continuation of this, but I wanted to share with you, you know, the first repair that we've seen on these Nexus S1. And let's hope that we can get this customer back up and running. We won't know until we get the new caps in. Thanks for tuning in. Keep it out for more of our videos. Like and subscribe. Hit us up on ixtech.xyz if you need any repairs or any accessories for your miners. We develop most of our accessories in-house. All of our 3D prints are done in-house right here in Ohio. If you got any questions, reach out. Thanks again. Appreciate it. See ya.